Filling of orbitals by electrons. Now, first one, electrons are filled in orbitals based on 5 rules. Okay, in that first one, Aphaba Principle. Now, what is the meaning of Aphaba Principle? Actually, Aphaba, it is not a scientist name. This is a German word. This is a German word, means to construction, or I can write building up, construction or building up. Now, what is the meaning of Aphaba Principle? According to this principle, electrons first occupy lower energy orbital. That means filling of electron takes place based on the increasing order of energy of the orbital. Okay, filling of electron takes place increasing order of energy of the orbitals. This is called as a Aphaba Principle. I will write it here. Filling of electrons. Okay, filling of electrons takes place according to increasing order. What is the meaning of increasing order? First you have to place lower energy, then higher, like that it will go. Increasing order of energy of orbital or a subshell. This is a Aphaba Principle. Now here sequence of energy level of atomic orbitals is written. Okay, this is if n is equal to 1, so it becomes what is how many subshells are possible? N is equal to 0, so only one is orbital is possible. If n is equal to 2, okay, if n is equal to 2, here I will write n is equal to, what are the L values? 0 and 1. 0 means it is nothing but a 2s, 1 means it is nothing but a 2p. So if n is equal to 3, how many subshells are possible? 0, 1 and 2. So 0 means S subshell, that is C, 3s. 1 means P subshell, 3p, and 2 means D subshell, 3d. Okay, so based on this it is written like this. Okay, so you can see here all these things. This is a sequence of energy level of the orbitals. Okay, now how we can write increasing order of the energy level of the orbital. I will tell you easy way of writing the increasing order of the energy level of the atomic orbital. See here, just I will put the arrow mark like this. You have to put the arrow mark. Okay, from 1 is, see, dotted line I have drawn, and then 2s. Okay, that means increasing order. Here I will write first 1s, after that 2s. You have to fill like this. Okay, then after 2s it comes 2p. So 2p, then 2p, it is 3s. Then after 3s, see how I am put the dot line. So 3p. Okay, so from 3p to 4s, then again I will put the dotted line, I will go up, then here, so it is a 3d. Okay, then 4p, okay, then it is a 5s. So like that we can write increasing order of the energy level. I hope you understood. Then see like this. After 5s it is a 4d. Okay, then it is a 5p, then it is a 6s. Then see how I put the dotted line. 4f, okay, it is a 4f, then it is a 5d, then 6p, then 7s. Again I have to put dotted line C, then 5f, 6d, okay, 7p, then 8s. So like that it will come. This is nothing but a Aphaba principle. Okay, it is nothing but a construction, or it is a building up of the energy level of the atomic orbital. So this part you have to recall. So here 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. Now the energy of atomic orbital is also decided by n plus L rule. N plus L rule. Okay, I will explain what is the meaning of n plus L rule. I hope you understood the concept of Aphaba principle. Aphaba principle means it is nothing but a construction of, it is a German word called as a construction or a building up. Now here electrons are filled according to the increasing order of the atomic orbital. So this is the increasing order of the atomic orbital. So 1s has a lesser energy compared to 2s, like that. Okay, so it is a increasing order of atomic orbital. This part you have to recall: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p and 5s. Okay, so write it down in your rough book: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. Okay, then I will teach you how to fill the electrons. This energy level is also decided by n plus L rule. Okay. Now, next one is the n plus rule. What is n plus L rule? Sorry, n plus L rule. Okay. Now here I have written increasing order of the energy level of the atomic orbitals. Please write it in your notebook. It is helpful. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p and so on. Please write it down in the notes book: increasing order of increasing order of energy level of the atomic orbital. This is required to fill the electronic configuration. Please write it down now itself in your notebook. Now I am going to explain n plus L rule. Now what is the meaning of n plus L rule? N plus L rule, it helps to decide the energy level of the each orbital. Okay, n plus L rule, it helps to decide the energy level of the each orbital. Now first I will compare with the 2s and 2p. Okay, so according to the increasing order of energy level, 2s has lesser energy compared to 2p. Okay, this I have taken. Now I will apply n plus L rule. Okay, n plus L rule. Now what is the meaning of n plus L rule? For each orbital I will apply n plus L rule. N means it is nothing but a principal quantum number. Okay, and L means it is nothing but a azimuthal quantum number you already studied. Okay, now n, since it is a principal quantum number, so what is a principal quantum number according to this? This is a principal quantum number. This is the n value. So I will write it here. And L means it is nothing but azimuthal quantum number. It gives the information about the subshell. So which subshell is present? Yes, subshell is present. So here I will write it down. If L is equal to 0, then what is a subshell? Yes. If L is equal to 1, then it is a P subshell. If L is equal to 2, then it is a D. If L is equal to 3, then it is a F subshell. Okay. So since L is equal to yes subshell means what is the value of L? That is a 0 value. So 0. So what is the n plus L? 2 plus 0. What is the answer you will get as a 2? Okay, here same I will apply here. So what is the n value? It is a 2, principal quantum number. L means it is since it is a P subshell. For P subshell, what is the L value? P subshell, it is L value is equal to 1. So 2 plus 1, answer is 3. Okay, that means Okay, if two different atomic orbitals are present, okay, its n plus value is different. If its n plus L value is different, then which you have to consider as a more energy, that is a n plus L value which has a more number, that you have to consider as a greater energy, that it has a greater energy. Okay, so in this case 2s and 2p, n plus L value for 2s, that is a 2, n plus L value for the 2p, it is a 3. So which has a higher energy, that is a 2p has a higher energy. So I will repeat according to this rule. If two orbital have different n plus L value, if two orbital have different n plus L value, if two orbital have different n plus L value, okay, then the orbital with the lower n plus L value consider as a lower energy. Okay, I will repeat it again. If two orbital have different n plus L value, okay, different n plus L value, then orbital which is having lower n plus L value, orbital having lower n plus L value, that orbital consider as a lower energy orbital, So 2s and 2p, in that which has a lower energy orbital, 2s has a lower energy orbital because its n plus L value is less. 2p has a n plus L value is 3, so it has a higher energy value. This is one concept of n plus L rule. I hope you understood the concept. Okay. One more concept, that is 3D and 3p. This I will take as example 3D and 4p. Now I am going to apply n plus L rule for each orbital. Okay, now n, what is the value of n? That is for this it is 3. Okay, now it is a D. So D sub shell, what is the value of L for D sub shell? Here it is written for D sub shell, what is the value of L? It is a 2. So 3 plus 2 you will get as answer as a 5. Now in this case, what is the value of N? That is a 4. Okay, this 4. And L, which subshell is present? P subshell is present. What is the value of L if it is a P subshell? P subshell, value of L is 1. Okay, so 4 plus 1. What is the answer you got? 5. In both the case, n plus L value it is same. In both the case, n plus L value is same. So in this case, if such cases are there, then you have to see the n value. Okay, based on the n value, you should decide which has a lower energy value and which has a higher energy value. If n plus L value, if it is the same, okay, if n plus L value, if it is the same, then orbital with the lower n value, okay, I will repeat it again. If n plus L value is the same, then orbital with the lower n value, as considered as a lower energy orbital. Okay, now here in this case n plus L value it is same, 5. Okay, now so what you should see now, orbital having a n value, orbital of n value. Now this, what is the n value of 3D? That is 3. Okay, what is n value of 4p? That is 4. N is equal to 4. So n value, if it is, that is a n value 3D has a lesser n value compared to 4p. So energy of 3D orbital is less compared to 4p. That means what it says, the second rule of n plus l, that it is if n plus value it is same, then orbital with the lower n value is considered as a lower energy orbital. I hope you understood the concept. Okay. So the energy of the atomic orbital we can decide with the help of n plus L rule also, or we can write based on the Aphaba principle also. Okay. The next rule is Paulis exclusion principle. Now Pauli is a scientist. In 1925, Paulis stated the rule that is called as the Paulis exclusion principle. Now, according to him, what he told, according to this rule, no two electrons in an atom, no two electrons in a same atom, okay, can have the same set of values of all the 4 quantum numbers. No two electrons in an atom can have the same set of values of all the 4 quantum numbers. Now, what are the 4 quantum number you studied? That is a principal quantum number, okay, azimuthal quantum number, that is L, magnetic quantum number, okay, M, and spin quantum number. So, principal quantum number, that is N, azimuthal quantum number L, magnetic quantum number M, and spin quantum number S. Okay, now if I take hydrogen atom, okay, or just I will consider one orbital, okay, 1s orbital. Now S has a capacity to fill, each orbital has a capacity to fill 2 electrons. Now if I want to write in a box form structure, I will write like this way, okay, this indication of filling of electrons. Okay, now here in 1s orbital, how many electrons are present? 2 electrons are present. This is 1 electron, this is another electron. So in same orbital, I have two electrons. Now for each electron, I am going to write 4 quantum numbers. Okay, for each electron. Okay, now for this electron, I am going to write n value. So n value. N means principal quantum number. Now this electron is present in which principal quantum number? That is n is equal to 1. So I will write n is equal to 1. Now L value. L means it is nothing but a subshell. So which subshell is present? This S subshell is present. If S subshell means what is the value of L? That is 0. So M. Now M means if L is equal to 0, what is the value of M? That is 0. So what is S? S means it is nothing but a spin quantum number. Now there are 2 spin value. One is a plus half, another one is a minus half. Now this I will consider as a plus half. Okay. Now next, same information I will write it for this electron. Okay. I finished writing this information. Now I am going to write quantum numbers for this electron. So what is the value of n for this electron? This electron is present in 1s orbital. 1 means principal quantum number. What is the L value for if it is a S subshell? It is a 0. Okay, and M. If L is a 0, then what is the value of M? It is a 0. What is the value of S? Spin quantum number. Since for this I have considered as a plus half clockwise direction. This is an anti-clockwise direction, so I have to consider as a minus half. Now, N, L, M, you will get same answer in both the case. For both the electron, you will get same. Okay, but where it will differ? S quantum number, that is a spin quantum number. First electron it shows a plus half, second electron it shows a minus half. That means there is no 2 electrons. That is 2 electrons in an atom of same set of, okay, cannot have the same set of values of all the 4 quantum numbers. Electrons in an atom of the orbital cannot have the same set value of all the 4 quantum numbers. Where it will differ? N, L, M, you may have a same number, But where it will differ, of course, spin quantum number, it gives a different value. As a one electron, it gives plus half, another one it shows a minus half. So no two electrons in an atom, you will not get same answer. So same set of value of all the four quantum numbers. Where it will change in a spin quantum number, it will change. Okay, so that's why how we are starting. No two electrons in an atom can have the same set of values of all the four quantum numbers. Okay, so in S spin quantum number, it will change. So this is a Paulis exclusion principle. All these principles are very important. Questions are asked for 2 marks. Okay, state and explain Paulis exclusion principle. Like this, it will be asked. So statement as well as example you should write. Hund's rule. Next rule is the Hund's rule. So I finished. First one is Aphaba Principle, N plus N rule. Third one is a Paulis exclusion principle. Fourth one is a Hund's rule. Okay, Hund's rule. This is also very important for the sake of exam. Usually it is asked for 2 marks. State and explain Hund's rule. Now what is the meaning of Hund's rule? Now here, how it is filled. Okay, it explains the electronic configuration. That means how electrons are filled. Okay, in the orbital. Electrons in a subshell are paired only when all the orbital of a subshell, okay, when all the orbital of a subshell is half filled with the parallel spin. Okay, that means a pairing of electron takes place. Simply, I can say that pairing of electron takes place. Electron takes place in P, D and F subshell in other words, no pairing of electron takes place. Okay, no pairing of electron takes place in PD and F subshell until all the orbitals, okay, all the orbitals of these PD and F subshell are singly occupied by electrons. This is a simple meaning of this. Electron in a subshell are paired only when all the orbital of subshell is half filled with a parallel spin. Or I can write like this also. No pairing of electron takes place in PD and F subshell until all the orbitals are singly occupied. I will show you how it is. Okay. Now, first I will explain one by one. First, that is I will take example as a lithium. Now, what is the atomic number of lithium? It is 3. So, how to write? It is 1s2. Okay, 2s1. Now, before filling the electrons, I will tell you. So, s orbital has a capacity to fill 2 electrons. P orbital has a capacity to fill 6 electrons. D orbital has a capacity to fill 10 electrons. F orbital has a capacity to fill 14 electrons. Okay, this you should keep it in your mind. S has a capacity to fill only 2, P has only 6, D has only 10, F has only 14. Thus, you should keep it in your mind before filling the electrons in the each atomic orbital. Okay, now, so one by one we'll learn. Now here 1s2, 2s1. So 3 electrons I filled. Same thing I will write it in the form of box form structure. 1s means S has a 1 box. Okay, so how many electrons are present in 1s? That is a 2 electron. That is 1 electron has a upper spin, another one has a anti-clockwise direction. Like this I will write. Okay, now 2s has how many electrons? Only 1 electron is present. So 1, like this I will write. Okay, now lithium. After lithium it is a beryllium. It is atomic number is 4. Okay, so 1s2, 2. So box form structure I will write 1, 2 electrons I have written in the 1s orbital, 2s, how many electrons I should write? 2 more electrons I have to write. Now this. Now after beryllium it is a boron. So atomic number is 5, 1s 2, 2s 2. Now 4 I finished. Now I am moving to the next, because S has capacity to fill only 2 electrons. So now I am moving to 2p. Okay. So 2p, how many electron I should fill? Only 1. So that 2 plus 2 4, 4 plus 1 5. So 5 electrons I filled. Now 1s, it is like this, you have to fill. In 2s 2 electrons are there. P, in P, how many orbitals are present in P? That is a px, py, pz, 3 orbitals. I already explained this concept. Px, py, pz. Okay, so in P 3 orbitals are present. In P subshell 3 orbitals are present. You should keep it in your mind. Okay, now here this 1 electron I will fill like this. Okay, or same, even I can fill here also, no problem, because each orbital, okay, orbital of the p subshell has an equal energy. Orbital of the p subshell has an equal energy. This is, if I consider this is a 2px, 2py, 2pz. 2px, energy of 2px is equal to 2py, and the energy of 2py is equal to 2pz. So I can fill any boxes. Either I can fill in first box, second box, or third box also, no problem. Okay, so like this also I can fill, no problem, or this way also I can fill. Okay, so any, okay, clockwise direction or anti-clockwise direction, anyhow I can fill. Okay, but just I will consider I will use this pattern, that is this way first. Okay, now next one is a carbon. Atomic number is 6. 1s2, 2s2, 2p, 2. Of course, here you don't have any problem. Directly I am filling, pairing the electrons. But here now, okay, 1 electron I already filled. Now 1 more electron. Where is supposed to fill? Whether I have to fill here or I have to fill like this, or whether I have to fill this way, this way. Now this is a question, how I should fill. Okay, now here what it is explained, Hund's rule means it is nothing but you have to, no pairing of electron takes place. Okay, so you can't pair the electron until all the orbitals are filled singly, until all the orbitals are filled singly with the parallel spin, Now, so this is wrong, because already have paired. So pairing does not takes place. Okay, till all the orbitals are filled. Okay, now of course this one. Now second electron I have to fill here. Oh, this way. Now what is the meaning of parallel spin? Parallel spin means, see here I have selected like this. So 1 more electron I have to fill this way only. This is called as a parallel spin. Okay, or I can write like this also. This way also possible. Okay, or I can write like this also. This way is also possible, but this method of filling is wrong. That is singly occupied, but like this we should not fill, because it is not a parallel spin, it has an opposite spin. Okay, so it should be a parallel spin. I hope you understood the definition. Go back to the statement. What is the Hund's rule I have told, what I explained, what I have written on the board here only. That is a pairing of electron does not take place until all the orbitals of P, D and F subshells are filled singly or occupied singly with the parallel spin, So spin has to be parallel. Okay. Now nitrogen. Next element is nitrogen. Atomic number is 7. 1s2, 2s2, 2p, 3. This I will not write directly. I will write here. So 1, 2, and 3. Okay. So now here singly occupied. All the orbitals of a p subshell. All the orbitals of p subshell are singly occupied, or this is also called as a half filled. This is also called as a half filled. Now all the spins are parallel. See, all electrons are in the upper direction. Okay, so it is a filled, singly occupied, and with a parallel spin. Okay, now one more example I will write. Atomic number 8, that is oxygen as atomic number 8. Okay, so electronic configuration 1s2, 2s2, 2p, 4. 2, 2, 4 plus 4, 8. So 8 electrons. Now this part I will write. So 1, 2, 3. Now fourth electron, it started pairing. Now it started pairing. So what it is told? No pairing of electron takes place until each orbitals of p subshells are singly occupied by the parallel spin of electron. Singly occupied by the parallel spin of the electron. Now each orbitals are filled with the single electron. Now one more it is left. So now pairing takes place. Okay. So one more example I will take continuously as a fluorine. Atomic number fluorine 9. So it is 1s2, 2s2, 2p, 5. So here P has 3 boxes. 1, 2, 3. Parallel spin 3. Now pairing takes place. 4th. This is a 5th. Okay. Now next neon. This is a noble gas. Okay. So atomic number is 10. Now 1s2, 2s2, 2p, 6. So this I will write. 1, 2, 3. Singly occupied each orbital. Now fourth electron starts pairing. 4, 5, 6. Now it is completely filled. Now this is a completely filled p orbitals. Completely filled p orbitals. So p has a, so this you have to keep it in your mind. S has a capacity to fill 2 electrons. Okay. P has a capacity to fill 6 electrons. D has a capacity to fill 10 electrons. F has a capacity to fill 14 electrons. Okay, I hope you understood the concept of Hund's rule. So, no pairing of electron takes place until all the orbitals of P, D and F subshells are singly occupied with the parallel spin. Okay, singly occupied with the parallel spin of electrons. This is a Hund's rule. Now, electronic configuration. Electronic configuration. Now up to near neon. Okay, so I will explain how to fill the electrons. Okay, in a atomic orbitals. So all the rule you have to keep it in your mind. Aphaba principle, Paulis exclusion principle, N plus L rule, then Hund's rule. Okay, now up to 30 you should know atomic number 30. Up to 30 you should know how to fill the electronic configuration. Few elements as exceptional. Okay, that also I will explain in this concept. Usually a question will be asked, okay, about electronic configuration, like write electronic configuration of hydrogen atom, or like write electronic configuration of lithium, which is having a atomic number 3. Okay, so you should know atomic number as well as its element. Okay, so from hydrogen to neon I already explained while explaining the Hund's rule. Okay, filling of electrons from hydrogen to neon, I already explained while explaining the Hund's rule. Now from sodium onwards I will explain. Atomic number neon is 10. Okay, this is from hydrogen 1. Now sodium atomic number is 11. So how to fill? 1s2, 2s2, 2p, 6. Now 10. So one more electron I should write. So that is a 3s1. Okay. So while explaining, please write it down in your notes book or in your rough book. Okay, again and again, so that you can understand and understand more clearly. Okay, and then it becomes you have to practice. Okay, so now sodium. After sodium, it is magnesium, atomic number 12. Okay, 1s2, 2s2, 2p6, 3s2. Aluminium, atomic number 13, 1s2, 2s2, 2p6, 3s2. Next it is a 3p. Okay, so 10, 12, 13. Next it is a silicon, atomic number 14, 1s2, 2s2, 2p6, 3s2, 3p2. Okay, phosphorus 15, 1s2, 2s2, 2p6, 3s2, 3p3. Okay, then sulfur 16, 1s2, 2s2, 2p6, 3s2, 3p4. Please write it down in your notes. Okay, so that you can practice. After that, chlorine 17. You should buy atomic number as well as element up to 30. You should know. 1s2, 2s2, 2p6, 3s2, 3p5. Next, argon. Argon is a noble gas. 1s2, 2s2, 2p6, 3s2, 3p6. So it is a 3p6. Okay. Now here. Potassium 19, 1s2, 2s2, 2p6, 3s2, 3p6, 10, 12, 12 plus 6, 18, 4s1. Okay, next is after 3p6, which orbital comes? 4s. Okay, so 4s1. Now this also written as, this I can write like this also. Argon. Argon, what is atomic number of argon? It is 18. So from 1s to 3p6, it is a argon electronic configuration. Now you can write like this also. This is another method of writing. Okay. So next, calcium 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Also written as, how it is written? Argon 4s2. Like this also you can write. Okay. Next it is a scandium. Atomic number 21, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now here up to here 20. Okay, now it comes as a 3D1. This is a 3D1. Okay, after that titanium 22. So what happened here, it becomes a 3D2. Same configuration, 3D2. Titanium, then vanadium 23, 3D3. Now chromium 24. So this also I will write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, this is 2. Okay, here vanadium 23, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, it becomes 3. Okay, now chromium. Chromium, it is exception. This I will erase. Chromium 24. This is very important electronic configuration. Usually question will be asked based on chromium. Okay, so chromium. So usually how we are going to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay, 3d, 3. Actually like this we are going to write 10, 20, 23. This becomes 4. So 24. Okay. Now, so this is a way we are going to write actually. Okay. But here, what happened? This, since it is it has a exceptional configuration. That means we are going to write like this for chromium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d, 5. This is a correct configuration. This wrong electronic configuration. Why? I will tell you. Now here in the box form structure 4s, how many electrons I should write? 2 electrons I am going to write. Okay. Now in the d orbital, d, it has a 5 box. D has a 5 box. Okay, D has a 5 box. Now 4 electrons are present. So how to fill? 1, 2, 3, 4. Okay. Now here what happens? Here I will write 1 electron and in D 5 electrons are present. Okay. Now here, this is called as a half-filled configuration. Half-filled. D orbital is half-filled. Okay. So half-filled configuration is most stable. Okay. Here what happened? So since half-filled configuration most stable, the electron which is present in the 4s, one electron will jump here. Will jump to this orbital. Okay, so electron which is present in the 4s orbital, one electron, it will jump to this and it gets a half-filled electronic configuration, because half-filled electronic configuration is a most stable electronic configuration. So based on that concept, which one is the correct electronic configuration for chromium? That is a 4s1 3d 5. So that's why this is a exceptional case. Okay, due to half-filled electronic configuration is most stable, that's why it shows a 4s1 3d5 electronic configuration. So this is very important electronic configuration. Question will be asked either for 1 marks or for 2 marks. Okay, now I will tell you how question will be asked. That is, the one way of asking question is write electronic configuration of chromium. atomic number is 24. Like this. So if question is asked like this is usually like this, it is asked for 1 marks. Okay. Or another way of asking, write electronic configuration of an element having atomic number 24. Write electronic configuration of an element having atomic number 24. Name the element. Okay, this is asked for 2 marks. This is asked for 2 marks. So write electronic configuration of an element having atomic number 24. Name the element. So how to answer? First you should write electronic configuration. Okay, and you have to name the element. So what is the name of the element which having atomic number 24? It is a chromium. It is a chromium. I hope you understood the concept. Okay, then so same thing, up to 30 you should write. Okay, remaining, manganese atomic number is 25, iron atomic number is 26, cobalt atomic number is 27, nickel atomic number is 28, copper atomic number 29, zinc atomic number is 30. So up to manganese, iron, cobalt, nickel, you have to write the electronic configuration. This is a homework. Write the electronic configuration and send it through WhatsApp. Okay, now this I will write. Again, this is exceptional. Okay, so electronic configuration of copper is 29, atomic number is 29. So I am going to write now 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Now 10, 20, it is 9. Okay, now but here what happened, again this electron present in the 4s, 1 electron, okay, will jump to 3d orbital. It becomes 10 because to attain a stable completely filled configuration. Why it will do like this? To attain stable electronic configuration. To attain stable electronic configuration. Okay, to attain stable electronic configuration. Stable, which is a stable electronic configuration? Here it gets a, while jumping, after jumping, it gets a completely filled configuration. Okay, I already told half filled configuration is also stable configuration, and a completely filled electronic configuration is also stable configuration. Now 3D. 3D means it is nothing but how many orbital? It is a 5. 1, 2, 3, 4. Okay, 5. So here 5. In d orbital 10 electrons are present. So 5, 6, 7, 8, 9, 10. So it is a completely filled orbital. So this is a more stable electronic configuration. Okay, I hope you understood. Now last one, it is a zinc. It has atomic number is 30. This also you have to write in your notes book and send it through me as a homework. Okay, so I hope you understood the concept of electronic configuration. Now by this I am completing chapter 2, that is a structure of an atom. Thank you.